Good day, everyone. Welcome back. We're continuing with the third lesson in Unit 6 of Math 10C today. Unit 6 deals with relations, equations, and graphs, and today we're going to be looking at something called domain and range. And like much of other topics in this unit, this is something that's going to follow you into the grade 11 and 12 topics that you learn in high school math, whether it's in Dash 1 or Dash 2. So it's a very important set of ideas. The nice thing is, because you revisit it in grade 11 and 12, is you're going to get more and more practice between now and then. So we're looking at determining what's called the domain and range of a relation, whether we're looking at the graph or whether we're given a description of the relation or an equation of the relation. The goal today is for you to be able to find what we call the domain and what we call the range. And this can be found on page 10 of your current unit handout. First of all, we define domain as being the set of all of the first elements of the ordered pairs in a relation. Don't forget that every point on a graph of a relation can be described using two numbers. We call that pair of numbers an ordered pair. And the first number in that pair is always the x-coordinate. In other words, when I say the domain of a relation is the set of the first elements of the ordered pairs, I'm saying the domain is the set of all of the values of x in the relation. Since the x variable is always the independent variable, we could say that the domain is the set of all of the values of the independent variable. The range of a relation is the set of the second elements. In other words, the range of a relation is the set of all of the values of y. And if you want to call that all of the values of the dependent variable, you certainly can. So we're going to get lots of examples here and practice with determining domain and range. Here's a relation given in graphical form, and it's kind of a strange relation. We need to, first of all, make sure that we know what each of these 2 points on the end of the relation are. The point on the left is a solid point, and that means that the coordinates of this point, which we can read off of the graph, let's see, -6, comma, and the y-coordinate is 5. Those are the coordinates of that point, and that point is a solid point on the graph, which means that point is part of the relation. On the other hand, on the other end, if we read the coordinates of this so-called point, it has an x-coordinate of 3 and a y-coordinate of -4, but because that point is what I call a empty point or a hollow point, that point is not part of the relation that this graph is communicating to you. So let's talk about domain right now. The domain is the set of all of the values that x can have on this graph. So I'm going to highlight a particular point, this point right here, and it has an x-coordinate of -6, and I'm going to move that point to another location that is part of the relation, and the center of that blue point has an x-coordinate of -5. And the center of the point here has an x-coordinate of -4. What I'm getting at is that all of these numbers, -6 for an x-coordinate, -5 for an x-coordinate, -4 for an x-coordinate, these are all numbers for x that are in the domain. And since this is a line connecting the points, not only is -6 an x-coordinate in the domain, and -5 an x-coordinate in the domain, any number between those two is in the domain. And if you follow this blue point and imagine looking at all of the x-coordinates we're covering, we are covering x-coordinates all the way from, I don't know if I'm going to be successful in doing this, I'm trying to move 2 things at once, but all of these x-coordinates are part of the domain. So x can be anything from -6, greater than -6, all the way up to not up to 3 because that point is not allowed, but up to just before 3. And there's a very unique way for us to communicate this domain. It's using a number line. So I'm going to mark off 2 points on the number line. One of the points, which is on the left, is the minimum value that x can have. One of the points is on the right, and it's kind of the maximum value that x can have, although it can't really be equal to that. Now, how do we communicate that x can be anything between -6 and +3, and it can be equal to -6 but not equal to +3? The answer is we do this. We put a solid dot here at -6 on the number line. We put an empty dot at +3. We should label this as being x and we draw that. And what we're saying is x is allowed to be any value between -6 and +3, but equal to -6 and not equal to +3. Now, there are other ways that we can write that domain. One of them is to use the following notation. We say that x is a set of numbers with the minimum number being -6, anything from that up to, but not including 3. We use the square brackets to indicate that x can be equal to that number, and we use the round brackets to indicate that x is not allowed to be equal to that number. And finally, there's a third way of doing it. The third way is to write the minimum value of x, and then x and the maximum value of x, and we put a less than or equal to sign to the left of x, and we put a less than sign to the right of x. And what this is saying is two things. It's saying that -6 is less than or equal to x, and it's saying x is less than 3. And if you think about both of those carefully, -6 has to be smaller than or equal to x. Definitely that's the case. X is some number in here on my number line. So -6 is definitely less than or equal to x. And the second statement says x is less than 3. And that is always going to be the case. For any value of x that's allowed, x will be less than 3. And for any value of x that's allowed, -6 will be less than or equal to x. And if we take these two statements, everybody, the x is less than 3 and the -6 is less than or equal to x, and we just bring them together, we get that statement that I wrote. So those are the three ways we can describe the domain. Let's look at the range. Well, the range is something that we are going to now be looking at the vertical features of the graph. This is the lowest value of the graph in terms of y, -4. But again, it can't be -4. When we look at the graph, the highest value of x is over here at, pardon me, when we look at the graph, the highest value of y is 5. So y has a range from -4 up to 5. Can y be equal to 5? Yes. Can y be equal to -4? No. So what do we write for the range? For the range, if we want to use a number line, we're going to draw a number line, and I know it's about y, but we still draw our number lines horizontally. So I put a y here. I put the smallest value of y, which is -4, to the left. I put the largest value of y, which is, I'm going to have to look at the graph again, +5. and I connect these two, but I use an empty set or an empty dot or an empty point for -4 because y is never at -4, and a solid one for 5. Of course, what I can do is write the following. I can write -4 is less than y, which is less than or equal to 5. Or I can write y is the set of numbers between -4 and 5. Y cannot be equal to -4, so we use a round bracket where it's not equal to, and y can be equal to 5, so that's where we use a square bracket. Let's try another one. Well, this is an interesting one. It's a circle, and when you take a look at the smallest value of x, we're reading x coordinates by looking up at the x-axis. The smallest value of x that is on this circle occurs in this location, and the largest value of x occurs at this location. So there's a minimum value of 1 for x and a maximum value of 7 for x. I'm not going to use the number line anymore. Just to save a bit of time, I'm going to use the interval notation and the inequality notation. So with the interval notation, we would say x is the set of numbers between 1 and 7, and x can be equal to 1 or equal to 7, so we use square brackets. I can instead use this inequality notation and say 1, which is the minimum value of x, is less than or equal to x, and x has to be less than or equal to the maximum value, which is 7. The direction of these inequalities is always less than. For the range, we're simply going to turn our gaze sideways and look at the smallest value of y, which is down here at -3, and the largest value of y is up here at +3. So for the range, we can write y is the set of numbers from and including -3 up to and including +3, or we can write -3 is less than or equal to y, which is less than or equal to +3. Let's look at another one now. Well, there is a minimum kind of value for x. It's over here at x equals -2. So if we want to use the interval notation, we would say x, and it's -2 for the minimum, but we put a round bracket because x can never equal that point because of the empty point drawn there. The biggest value of x is +infinity. This graph continues to the right forever. If I were to take a look over here, would the graph exist at this particular value of x? Sure, it would just be way up top somewhere. But there would be a point there. So this graph continues to the right, and what we would say is the maximum value is infinity. We always use a round bracket when it's associated with infinity, because you can't really reach infinity. With the inequality notation, it's a little bit different. All we're going to do here is say that x is any number greater than -2. If we were to draw a number line, it would look like this. We would have -2 here, and an arrow to the right. And that's the same thing as saying x is greater than -2. With our range, the minimum value of y is -3, so we could write y is greater than -3. Just to show that to you, here's the minimum value of y, negative 3 vertically. Of course, it can't be equal to it, so we don't say y is greater than or equal to it. We just say y is greater than negative 3. And if you want, you can say y is the set of numbers from but not including negative 3 up to but not including infinity. Because of course you can't get to infinity. No matter how close you get to infinity, you're not there yet. So there's the domain and range. Interesting one here. Let's talk about the domain first. When you're talking about minimums and maximums for domain, you're always looking to the left and the right. Wherever the left-hand part of the graph starts, that's where the domain starts. And we can see there's an x-coordinate of 0 being the minimum. So we can write x goes from and including 0. And this point right here is a point that has an x-coordinate of 0. It doesn't matter that this point up top is an empty point for x. X is still equal to 0 somewhere on the graph. And the maximum is at 5. Or you could write 0 is less than or equal to x, which is less than or equal to 5. For the range, we're going to look the other way. The lowest value is the minimum y. The largest value or the highest value is the maximum y. So what would we write for the range? We would say that y is the set of numbers from and including, let me erase that so you can see where it is, 2 up to but not including 7. And then you could write 2 is less than or equal to y, which is less than 7. The square brackets mean it can equal, the round brackets mean it cannot. Another one, when you look at the domain is negative infinity to positive infinity for x. Because these two arrows go to the left and to the right forever, you will always be able to look at bigger and bigger values of x on either side, to the left or the right. I know that you'll look at this and go, yeah, but it's going up. It is going up, but it's going to the left and the right at the same time. We typically don't use this notation for this situation. I've never really seen this notation for this situation. What we do instead is we write the following. And this goes back to the number systems that we learned. What this means, we learned the number systems back in Unit 2 or 3. What this means is x is any real number. What about y? Well, the minimum value of y is 2. And there is no maximum. It just keeps going up and up and up forever. So for y, we can say it's from and including 2 up to, but of course never including an infinity. Or you could say y is greater than or equal to 2. Next one, well, this is kind of an oddball thing. Don't let it confuse you. We just don't have a simple way of talking about the domain as being some kind of continuous set of numbers. All we're going to do is we're going to say x is the following set of numbers. What are values that x can have on this graph? Well, x can have a value of negative 3. X can have a value of positive 1, positive 2, and positive 3. So that's what we write. And then we do the same thing for y. What are the values that y can have? So we look in the other orientation. Y can have a value of 2 or 3 or 4 or 5 or 6. And that's it. Now, whenever you're given a table of values, we typically assume that x comes first and then y comes second, which means that s is the independent variable which is associated with domain, and v is the dependent variable which we associate with y. So what is the domain? The domain is, we don't have to write the word domain here because it's not x. S is the set of numbers that are -3, -7, 1, 3, and 6. We do not need to list the number 1 twice. The range, well, those are the v's, and they are the numbers that include 5. I shouldn't even say it that way. It's not the numbers that include 5. It's the following numbers: 5, 1, 6, 8, and 7. While this is a set of ordered pairs, don't forget that ordered pairs are written in the x comma y form, which means that the domain is 1, 5, 9, 13, 17, 21, 25, and 29. The range is the set of all of the y values, which looks to be 1, 2, 3, 4, 5, 6, 7, and 8. So that's domain and range with just some practice off of graphs and other data sets or lists of ordered pairs. Let's take a look at a different question now, and we're going to use this question to kind of get used to using our graphing calculator. If you still have not got a graphing calculator, then it's time to get one. You need to have one to proceed in this course. You're given the equation of a relation P equals 2.4r minus 16. You're told the domain. Now they've written it with this element of symbol. I would prefer at this level just to write r with a colon. But either way, you should know what this means. It means 0 is less than or equal to r, which is less than or equal to 50. And we want to know what the range of the relation is. Well, I'll take you back to the previous lesson. Since r is the independent or x variable and it has an exponent of 1, that means this is a degree 1 relation, which means it's linear. And even though we're asked for the range right now, I'm going to kind of combine finding the range with doing what we're doing in B at the same time. So we're going to grab our graphing calculator. And it says we want to sketch the relation using our graphing calculator. So you're going to go to the y equals button, which is in the top left portion of your calculator. And you're going to enter in 2.4x. X is right beside the green key, minus 16. Now we're going to learn how to use our graphing calculator by setting up the window. You're told that r is from 0 to 50. So we went to y equals, which is right here. We entered 2.4x minus 16. To get the x, we hit this key, and now what I want everybody to do is go to the window key. This is going to be where we set up our axes. So I hit window, and it says X min, X max. Well, we want to go from 0 to 50. So I'm going to put 0 for X min, 50 for X max, and X scale is going to be where the calculator puts a little mark on the graph. And I'm going to put the number 10, which means in a minute when we look at the graph, we will see a window setting for X from 0 to 50, and it will be marked off in increments of 10. Now, we don't know what the Y values are. But what we can do, and this is a very basic calculation, is we can make a little tiny table of values. We can put in for we can put in for R 0 and 50, and we can calculate what V is. So all I'm doing is I'm going to my calculator, and in the next lesson we'll look at a more streamlined way of doing this, but I'm going to my calculator. I'm going to quit out of here, which is second mode. So when I quit out of there, I hit second and then mode to quit out and bump myself to the main screen. And I'm just going to go 2.4 times R minus 16. So 2.4 times 0 minus 16 gives me negative 16 for a V value when R is 0. And then I'm going to repeat the process for R equals 50. 2.4 times 50 minus 16, which tells me that it's 104. Well, we know this is linear, and we know that X or R goes from 0 to 50, and that now is telling us what Y or V is going from. So in our window setting, we're going back to window. Now we know what to do for Y min. We're going to go negative 16 for a minimum to 104 for a maximum. You can go up by increments of whatever you want. I'm going to go up by increments of 10. It doesn't matter. Never change your X resolution. And now we've entered in for Y the function. We've set up our window settings. That's what the graph looks like. We are asked to do a sketch of it. Well, there's my sketch. I don't really know that you need to write anything down. You're looking at it on your graphing calculator. By the way, we now know what the range is. The range is V is everything from and including negative 16 up to and including 104. Or if you like, negative 16 is less than or equal to V, which is less than or equal to 104. And we're done with that example, 2A and 2B. One final question. A Ferris wheel has a diameter of 193 meters. The maximum height of a rider on the Ferris wheel is 208 meters above the ground. The graph shows the rider's height relative to the ground for one rotation, and it takes 40 seconds for that to occur. So the distance from C to D, distance is maybe the wrong word, but this is time and it's in minutes. We know that that's 12 seconds. If you take, I'll just check to make sure, it's 40 seconds. 40 seconds divided by 60 seconds in a minute is 2/3 of a minute. So you start on the ride. At this point, it goes up to the top, and then it goes down to the bottom. And this is 2/3 of a minute. What are we asked here? We are asked for the domain and range of one ride. Well, the domain is going to be the time, and it will be from the beginning of the ride up to 12 revolutions. Now, each revolution is 2/3 of a minute. And one ride is 12 revolutions. 12 divided by 3 is 4. 4 times 2 is 8. This is an 8-minute ride. So this is the domain in minutes. What is the maximum height? You were told that the maximum height was 208 meters. You're told that the diameter, I got to go back and look at the number, is 193 meters. That means the distance from the lowest point to the highest point is 193 meters. Well, we can then figure out what this little distance is here, which is the height of the bottom of the Ferris wheel above the ground. You take 208 minus 93. I believe that's 15 meters. So this little distance is 15 meters, which means that the lowest value of your height is 15. So what is the range? The height is from and including 15 meters up to and including 208 meters. And I know it keeps repeating up and down, but it doesn't matter. That's the range. Domain and range is tricky. I understand that. And relying solely on a video for something like this where you don't get the nuances and subtleties of me pointing at things, and I can't see your face to find out whether you're getting it or not, means it's a little bit more work on your end. You're going to have to think about this more. You're going to have to buckle down and give this a really honest try. Not just watch the video once and go, I don't really get it, I'm going to move on. You got to figure this out. So there's lots of practice. I'm going to skip over example number 4. I think you get the idea. Yeah, we don't need to do number 4. We'll get more practice with your graphing calculator in the next lesson, which is what number 4 is mainly about. So there's some practice problems on page 301 of the text, 1 to 4 and 6 and 8. I hope that made sense. And just one final note here. This video will be up in Hapara on the Monday of the last week of school before our Christmas break. Some of you are definitely falling behind. You need to tell yourself that in order for you to complete the course successfully, in other words, you're going to finish all of the units and write the final exam by the final exam date of January 20th. Some of you are going to have to say to yourself, I got to take my math home over the holidays and I have to catch up. And that's just the way it's going to have to be for some of you. If you don't do that, if you don't commit yourself to that, then you run the risk of not successfully completing this course. So I hope to see you in school soon. Take care.